Hey everybody, in today's lesson we're going to continue our study of congruent triangles, and we're going to take a look at two more ways to prove triangles congruent. Remember that so far we've studied the side-side-side congruence postulate, side angle side, and angle side angle. So after today we'll have a total of 5 different ways to prove triangles congruent. So in our first method for today, it's called the AAS theorem, angle, angle, side. If two angles and a non-included side of one triangle are congruent to corresponding parts of another triangle, then the triangles are congruent. So in here, it's really important to take a look at the order in which the congruent pieces are placed in the two triangles. So we know that angle C is congruent to angle N. We know that angle R is congruent to angle O. And we know that side RY is congruent to side OT. So if you take a look at where they are, they've got angle, angle, side, congruent to angle, angle, side. Okay, so if you see that pattern happening in a pair of triangles, then the triangles are definitely congruent. So we're going to jump right into our first example, which is a proof. We're going to try to prove that triangle GHJ is congruent to triangle GIK. Now, this diagram is a little bit more complicated than some of the figures we worked with. In this case, we're working with overlapping triangles. So if you find triangle GHJ, that's this guy right here, GH, all the way out here to J. So I'm going to take and redraw that triangle separately. So if I just go off to the side and just draw that triangle. So it might be easier to identify the corresponding parts that are congruent if you separate the two triangles. The second triangle we're looking at is triangle GIK, over here from G to I, and then out to K. You see where they overlap? And they share angle G at the top. And that's going to come into play later on. So this is G to I to K. So let's start our proof with our given information and go ahead and include both pieces. So line segment GJ is congruent to line segment GK. So GJ congruent to GK. You can mark it in the original picture. And we're also given that angle H is congruent to angle I. And those are the two little angles down at the points. Okay, all that information was given to us. So if you think about it, all of our shortcuts involve 3 pieces, except for a theorem we're going to learn next. But here are the shortcuts we know so far. Side, 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 side angle, side, angle, side angle, and we just talked about angle, angle, side. And right away we're given 2 pieces of information, a pair of sides that are congruent and a pair of corresponding angles that are congruent. So I'm thinking that side, side, side is out. We're not going to use that one. And if you remember earlier, I mentioned that the two triangles overlap at G at the top. Since they both have angle G as one of their angles, you can mark angle G congruent to itself. All right. So in step 2, let's go ahead and say angle G congruent to angle G. And that's by the reflexive property. Now, so we have 2 pairs of angles and 1 pair of corresponding sides that are congruent. So we're going to knock side angle side off the list, and we've narrowed it down to 2 choices. So here's where you have to figure out which pattern your 2 triangles follow. In other words, do you have two angles in the included side or two angles in the non-included side. So check it out. I'm going to point this out in red in the top picture. So we've got angle, angle, side. And again, that's congruent to angle, angle, side. So the two triangles, triangle GHJ is congruent to triangle GIK by angle, angle, side. Our last shortcut only works if you have two right triangles. So if you plan on using this shortcut, you have to identify your triangles as being right triangles in your proof. So it's called the HL theorem, and that stands for hypotenuse leg. So it states if the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. Okay, so check it out. In our picture here, you definitely see we have two right triangles. The right angles are highlighted for us. And then this is the hypotenuse of the first triangle, FT. And JL is marked congruent to that, and JL is the hypotenuse in our second triangle. And then the other two sides, the two legs, are the sides that make up the right angle. And here we have FA marked congruent to JL. So by hypotenuse leg, we can determine that these two triangles are congruent. They have exactly the same size and same shape. So now we're going to take a look at some pairs of triangles and try to determine if they're congruent. And it says in our directions, state which congruence method or methods can be used to prove the triangles are congruent. If no method works, then we have to say none. Sometimes you have to look a little deeper and think about marking vertical angles congruent, or see if there's anything else that you can determine to be true about your picture. So in the first one, you see that we've got some segments marked congruent to each other, and we definitely have right triangles. But just because we learned the HL theorem, don't always assume that you want to use hypotenuse leg. It is true that the hypotenuse of that triangle below is congruent to the hypotenuse of the triangle above, but we don't know that any other segments are congruent, so hypotenuse leg is not an option for this first question. So then we have to dig a little deeper and go into marking vertical angles congruent. So now check it out. These two triangles are congruent by angle, angle, side. So the right angles are congruent, the vertical angles are congruent, and those segments are congruent. So angle, angle, side. In the second piece, we have a little right angle marked for us. If that's a right angle, that has to be a right angle because those two angles form a straight line, so they have to add up to 180. Now notice these two triangles are back to back, so they share a common side. So mark that congruent to itself. So in this case, we have right triangles where we have the hypotenuse congruent to the hypotenuse, and they both share a leg in common. So these two triangles are congruent by hypotenuse leg. In our third example, as it's labeled, there's not enough information. We have a pair of angles marked congruent and a pair of sides. But again, look for those vertical angles. If you mark those vertical angles congruent to each other, then you should be able to see how we could use the angle, side, angle congruence postulate to say that these two triangles are congruent. In our fourth example, we have two triangles that are like back to back. They share this side, IK, in common. So mark that congruent to itself, and these two triangles are congruent by the side, side, side congruence postulate. The next example, if you take a look, all three pairs of corresponding angles are marked congruent, but be careful, don't fall into this trap. Angle, angle, angle is not a congruence postulate, so these triangles are not congruent, okay? So there does not exist a postulate that would be able to be used to say that those two triangles are congruent. You have to know at least one pair of corresponding sides are congruent for any of our shortcuts. Okay, last one of this type. So we've got angle E. I'm going to mark it with an A for angle is congruent to angle B. Angle D, that's another angle, marked congruent to angle C. And then we have this side, DF, marked congruent to CA. So check it out. It is angle, angle, side. Or you can write side angle, angle. That would be appropriate too. Okay, for our last example today, we're going to do a proof, but you actually need 2 more lines in order to do this proof correctly. So we're given that angle B and angle D are right angles. And you can see that they're already marked as right angles in the picture. Right, I have a feeling that we want to do this proof, like say that the 2 triangles are congruent using the hypotenuse leg theorem. So let's check it out. We are given that EB is congruent to ED, and that is a pair of legs in the 2 right triangles. And we can see that the 2 right triangles share line segment EC, and that's the hypotenuse for each of those 2 triangles. So since we're going to use hypotenuse leg to say that the 2 triangles are congruent, the next thing we have to do is say that triangle EDC and triangle EBC are right triangles, because the hypotenuse leg theorem only works for right triangles. And we know they're right triangles just by definition of a right triangle. It has a right angle in it. Okay, in the next step, go ahead and include the other piece of given information, that EB is congruent to ED. I guess we could save a step if you wanted to include that in step number 1 as well. Okay, next we need to say that line segment EC is congruent to line segment EC by the reflexive property. Okay, now notice that our proof statement says that we're trying to prove that BD is congruent to we're trying to prove that BC is congruent to DC. So the next thing we have to do is say that our 2 triangles are congruent. So say triangle EBC congruent to triangle EDC. And again, we use the hypotenuse leg theorem. Okay, for our last step, this is something we haven't tackled before, but once we prove triangles congruent, then we can say that any other pair of corresponding parts are congruent. So since we said in step 5 that these 2 triangles are congruent, check it out. Here's line segment BC. It corresponds to DC in the second triangle name. So we're going to finish off our proof by saying BC is congruent to DC. And this is because corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Now, I'm not going to make you write it out like that every single time. We can take a little bit of a shortcut. So I just scoot this up a little bit, and here's the short way of saying that. C, P, C, T, C. Again, this is used anytime that you want to prove that corresponding parts are congruent. Notice before you say this, though, the line ahead of it has to be where you prove the triangles congruent to each other. Good luck on the homework.